So welcome to everyone on this call today. So this is a new webinar from Flusso, and we're going to discuss again the use of our flow sensor, the FLS110, for an application which is a fixed-wing drone application. Next slide, Kristen. So today will be two presenters, Chris here on the call, who is our head of system and application at Flusso, and myself, who is the head of marketing and product management for the company. Annie Rosenstand is our marketing manager, and she's going to be our moderator for today's session. The webinar is scheduled to last about 45 minutes, including 15 minutes of Q&A. All participants will be muted during the presentation for a better flow. We will have plenty of time for Q&A at the end of the session at the bottom of the hour. Feel free to type any questions in the chat box on the side of your GoToWebinar page. And also don't forget that you will get the slide and the recording of this presentation within a day or two at the end of this presentation. So no need to take many notes. And we are actually enjoying when you can ask a question live at the end of the presentation, as much as interactive as possible. That's what we want this session to be. Next slide, please, Chris. So today we're going to discuss a little bit about our view of the fixed-wing drone market, then the typical challenges in fixed-wing drone application in order to measure airspeed or wind speed. What would be the benefits of using the FLS110 from Flusso to have this new flow sensing solution for your drone? And we're going to close and wrap up with a short video of our FLS110 in action inside a drone. And then we're going to move to Q&A session. Next slide, Chris, please. So a little bit about Flusso to start. So we are a startup. We are a spin-off of Cambridge University in UK. We have been in business for about 5 years. This company has been started by a few scientists that have done a very successful startup in the past out of the Cambridge University startup ecosystem. We have actually a lot of talent in the semiconductor industry in order to design MEMS and to manufacture them. This is really the core of Flusso company. We have about 20 engineers or scientists in the company for a total of about 30 employees worldwide. Our first product was introduced about a year ago. So this is the product we're going to talk to you about today, the FLS110, our flow sensor. It has been introduced a year ago, and it is now in production, and we are shipping both evaluation kits and samples and customers samples for many months now. Next slide, please. So where is the FLS110 used? So the FLS110, because at its core, it's a very small, low-profile airflow sensor, really a great fit for high-volume, low-cost application because of the MEMS and CMOS manufacturing process. It is a very good fit for consumer appliance products. So here we have listed a few. It goes from a vacuum cleaner application, air conditioning units, air purifier, drones application, any types of consumer device where monitoring the airflow is critical to the customer experience or to the performance of the product. The second great application for the Flusso technology is in smart building. So everything related to HVAC system, air purification, which is a very hot topic, as you can imagine, with COVID and post-COVID situation. Everyone wants to improve the quality of the air, monitor the quality of the inside air of your office, and knowing the flow of your ventilation system is something very critical to have a good proxy for CO2 concentration, to adjust your airflow accordingly, and to reduce the number of particles in the air. The third pillar of our verticals is around industrial systems. So we have many applications in the industrial space, in either portable or fixed systems that have any type of airflow to monitor. Could be air, could be other type of gas as well. Could be gas detectors, portable or fixed. Could be any type of gas analyzer, where again monitoring the airflow or gas flow is critical for the performance of the equipment. So this is actually a field where we have many applications those days, and a great variety of application in the industrial space, basically. The last one, but not least, is what we call smart home healthcare products. It can extend to medical application as well. And again, it is all about portable or fixed equipment. Could be at home to monitor a patient remotely, or could be in the hospital in pre-ICU or ICU units on medical device to monitor many different type of parameters. Can go from oxygen flow going to patient, or pixometers, inhalers, or even sport performance trainers. So again, a variety of applications there, where again the small size and low cost of the FLS sensor is a great add-on for those applications. Next slide, please, Chris. So as we all know, the drone market, both commercial and consumer, are seeing a great growth in the last 10 years. This is a market which is already valuated at around 13 billion in 2020. The growth is double digit. I mean, actually, more than 50% over the next 10 years. So this is really a space that is really interesting, because there are many new application and development going on a daily basis, right? The one space that we are especially looking into with our technology is a little bit maybe more on the premium segment of this market. The commercial drones, the industrial drones that are used to do any type of surveying or mapping area for construction, or for oil and gas pipeline application monitoring, these kind of things, as well as monitoring of agriculture fields to improve the crop yields, or any type of city monitoring as well. So we all understand that the regulation is evolving for drones in many countries, and the performance of the drone is becoming more and more critical. By performance, we mean the range, the battery life, the span, and we believe our unique flow sensor can help the drone make its job safer and better. Next slide, please, Chris. Chris, do you want to take over from there?
Yes, thank you very much, Thomas. So just to cover a little bit of the different applications for drones for anyone who's watching the webinar who maybe isn't familiar with all of the different applications. Drones, I think, are expanding at this enormous rate, 50% growth year on year, because they provide a unique combination of convenience and performance for certain applications. When surveying and mapping areas for construction or surveying infrastructure, typically you would have to use cranes or climbing equipment or other equipment to look over the structure or survey the ground. And this is very expensive, very time consuming, and not very safe for the people who need to do that surveying. To contrast that with a drone that can just go and fly around a structure or fly across a site and survey and map that area, it doesn't put anyone at risk. It's very, very quick, very easy, and very cheap compared to a manual inspection, which is what was done before. When looking at agriculture, as we try and improve crop yields, but also try and reduce the amount of chemicals, pesticides, and fertilizers that we use on our crops to reduce the impact on the environment, we're looking for smarter ways to monitor the status of our crops. And here, a drone can be really valuable, because a drone can survey the fields every day and can identify the first sign of the first few plants becoming sick with a disease or a pest, or an area of plants that maybe needs some additional fertilization or something like that. And what this allows the farmer to do is to spray a lot less fertilizer, a lot less pesticide. That's obviously going to make the food healthier for the people that eat it. It's going to reduce the use of chemicals, It's going to reduce the impact on the environment and also the cost to the farmer as well. So that's really helpful. Within the urban environment, drones have found a wide range of uses in crime prevention. You can fit them with infrared cameras. They can fly over the urban environment and they can identify people who are lost or missing, or people that you want to find as part of crime prevention activities. In emergency response and safety monitoring, having an eye in the sky can be really valuable. If there's been some sort of disaster or some sort of accident, having a bird's eye view of the situation so you can identify the people who need help can make the response much more effective and end up saving lives in the long run. As we become ever more concerned about our environment and monitoring our impact on the environment, we want to have more understanding of how animals, endangered species, are moving through the environment, and also how they're interacting with other animals and also poachers and things like that. Drones provide a very low cost, very convenient way to monitor the environment. They can cover enormous areas of land, particularly fixed wing drones can cover enormous areas very easily. And they can monitor what's happening in those areas, identifying poachers, illegal deforestation and things like that. And finally, the one that I think we're all probably most aware of is drones for package deliveries. Now, obviously there are these last mile deliveries which are in development, but drones are already being used for things like remote mail delivery to islands, where it's much lower cost, much more convenient to have a drone fly the mail out there remotely and then return than it is to send a boat with packages. And so that's been trialed actually in Scotland, in the UK, for delivering mail to some of the more remote islands. So lots of different applications for drones, lots of areas where we can add value with them. For all of these drone applications, an accurate airspeed measurement is essential to optimize the performance of the drone, whether it's a fixed wing drone, which is what we're focusing on today, or multi-rotor drones. The FLS110 offers compelling advantages over existing differential pressure sensors that are typically used for this application in terms of size, weight, and critically performance. And you can see when we look at the size comparison between an existing solution from Maytech Systems, a digital airspeed sensor, that pressure sensing module is approximately 10 by 10 millimeters, and it has 2 large ports on it. If you compare that to the FLS110 in the image on the right, that's only 3.5 by 3.5 millimeters, so it's much lighter and much smaller as well. Drone applications bring with them certain challenges for ordinary MEMS pressure sensors. Typically, low-cost MEMS pressure sensors suffer with drift, which can lead to poor accuracy and repeatability, particularly at low air speeds. And this makes them unsuitable for multi-rotors and also unsuitable for fixed-wing drones that have a vertical takeoff and landing capability. In contrast, the FLS110 has really negligible drift and much better accuracy and repeatability, particularly at low air speeds. And this allows it to provide excellent performance on all types of drone and also be particularly useful in applications where you have a fixed-wing drone that maybe goes through a VTOL stage in its takeoff and landing. So these hybrid drones, as you can see in the image on the right, that take off vertically and then fly horizontally. FLS110 is really good for those applications. Also, we find that very accurate differential pressure sensors are often not cost-effective for very high volume applications. In contrast, the FLS110 uses an automotive qualified supply chain and a fully automated CMOS manufacturing process. And this allows us to achieve really world-leading price-performance ratio in high volumes, which is really ideal for drone applications. Of course, none of this matters unless the sensor can deliver the performance that's required for the application. And to help us achieve our performance, the FLS110 supports in-system and in-situ calibration. What this ensures is that any unit-to-unit variation of any part within your drone does not affect the accuracy of the final measurement. So variation in the design of the pitot tube, for example, or variation in the exact placement of the pitot tube on the drone, all of these things can be compensated for in the calibration of the sensor, and then you still get the best possible accuracy in the final measurement. We find that better than 5% accuracy is possible when you use multi-point calibration across the range of interest. And the FLS110 significantly outperforms more expensive competitor products in terms of accuracy and repeatability, particularly at low airspeed. And that's what the graph on the right here shows. So in the graph on the right, we have two plots. The red plot is the FLS110, and the blue plot is a competitor differential pressure sensor. And these are from two separate flights. You can see that the blue sensor really struggles to make an accurate reading of airspeed at low airspeeds, whereas the FLS110 is able to very accurately measure flow all the way down to 0. And it's also able to pick up the small change in velocity that is indicated by the launch of the drone before the drone accelerates. And this allows us to give more precise information for better control of the drone during that critical takeoff and transition to forward flight. So how does the FLS110 achieve this? Well, it's the world's smallest and lightest flow sensor. And this makes it possible to install it into even the smallest and most densely packed drones where space and weight is at a premium. The sensor uses a thermal flow measurement principle to measure mass flow through the sensor, and from that determine airspeed very, very accurately. The sensor is temperature compensated by an onboard temperature sensor and also pressure compensated by an external barometer. And this allows it to provide unparalleled accuracy regardless of the environmental conditions and over a very wide range of altitude. And as far as I'm aware, we're the only differential pressure sensor that offers this type of compensation. Traditional airspeed sensors are often sold as modules, and they sometimes come with an integrated flow fixture. This additional part can add a lot of cost and also make them difficult to integrate into more space-constrained designs. To contrast that with the FLS110, which supports many different types of flow measurement fixtures, orifice plates, venturis, pitot tubes, of course, and others. And also the FLS110 makes use of your resources that you may already have in your drone application, an existing microcontroller. And if you're using it with an existing microcontroller, it only requires 2 external resistors to operate the sensor. You can see in the image on the bottom right, the FLS110 mounted into a flow fixture. This is obviously designed for measuring flow, but if you attach this to a pitot tube, you can also use the sensor to measure airspeed. And now, if I can, I'll show you a little demo video to show you how it's installed in a drone.
First, I'd like to take you through the sensor module that's included with the FLS110 V6 evaluation kit. You can see that the sensor module PCB is really quite small, and on this side of the board it's dominated by this box header connector here, which allows you to easily connect this sensor module either to your application electronics or directly to the USB to I2C adapter provided with the evaluation kit, so you can plug the sensor directly into your laptop and start making flow readings. You can see also that there's a small microcontroller on this side of the board. This is an STM32 Cortex M0 core microcontroller, and it's responsible not only for driving the FLS110 sensor, but also reading the analog signals from the sensor and performing all the calculations necessary to convert those signals into a fully temperature and pressure compensated flow, differential pressure, or airspeed measurement. If we turn the PCB over and look at the other side, you can see that we have 2 components on the other side of the board. The first component is the FLS110 itself. It's 3.5 by 3.5 millimeters, so it's absolutely tiny, and you can see 2 small ports on the top of the FLS110. This is how the FLS110 interfaces with your flow path, and a small amount of air passes between those two ports and allows the sensor to make a very accurate measurement of mass flow, volume flow, differential pressure, or airspeed. This second component is a standard pressure sensor from ST Micro, and this pressure sensor can be optionally used to pressure compensate the flow reading for applications where you might expect a very large variation in the pressure in the flow path. For example, in a drone application where you might be operating a drone over a wide range of different altitudes and you need the absolute most accurate airspeed measurement that you can get, a pressure sensor can be used to pressure compensate the reading to achieve the best possible accuracy. For drone airspeed applications, we provide this adapter that converts the FLS110 interface, those two small ports there, into two slightly larger barb connections to easily be able to connect to something like a pitot tube. When you order your evaluation kit, your FLS110 sensor module will come pre-installed on this flow fixture. So I'm going to put the sensor module on here now. Once the FLS110 flow sensing module is installed on the adapter, it's very easy to connect it directly to a pitot tube. So this is a typical pitot tube that you might expect to see for a drone application. You can see that it's got some pressure tappings at the tip here, and it's also got some pressure tappings around the circumference of the pitot tube here. Now you're going to want to connect the tapping that goes to the tip of the pitot tube to the upstream port of the FLS110. And you're going to want to connect the pressure tapping that goes to the circumference to the downstream port of the FLS110. And so hopefully there you can see that I've connected it in that way. And the flow in the system is going to flow from the tip of the pitot tube down to the FLS110 and then back to the pitot tube and then out the pressure tappings on the circumference. And that's going to be the direction of flow. The final stage of installing the FLS110 into a drone is connecting it to the drone electronics. I'm just going to show you an example of how I've done it here. So here is the flight controller of the drone, and this flight controller will have a 3.3 volt supply, a ground supply, as well as the I2C SDA SCL lines. And what I've done is I've stripped back some of the insulation from this FLS110 box header cable, and I've soldered those wires onto the appropriate pins. So I've connected 3.3 volts ground and the two I2C lines, data and clock. And then all I have to do to connect my FLS110 to the flight controller is plug in this box header here. And there you have the whole system. You have the FLS110 V6 evaluation kit sensor module connected to the flight controller of the drone that's just here. And then the fluidic connection of the FLS110 is connected to the pitot tube, which you mount into the drone. And with this configuration, it's very easy to measure airspeed accurately with the FLS110.
Okay, so hopefully you enjoyed that video. I'll hand over to Thomas now, who's going to tell you a little bit more about ordering an evaluation kit. Thomas?
Excellent. Thanks, Chris, for the great demonstration, right? So of course, the best way for you to test our technology is really the evaluation kit, right? So that's a full kit that we developed about a year ago that is available from Cambridge and can ship within a week or two. And it can be shipped in different versions, right? So either you can just do a test on the bench. If you have an existing reference flow meters, you can test the FLS110 as just a pure flow meter on the bench next to another reference flow meters and compare the two of them. Or you can also receive a special module in order to do the test inside the drone, for instance, right? This is a full kit. You will get a USB adapter, you will get cables and the test fixture, the flow fixture, as well as the software to be in order to log all the data, to change the settings on your FLS110, change the range, the measurement range. So it's really a tool for development engineers. And usually you are up and running within 10 minutes. We have actually a video in our tutorial video section on our website to help you do the out-of-the-box experience seamlessly. And that's really our next step if you want to test our technology. Next slide, please. So I think we are at the bottom of the hour. We are perfectly on time. So I think it was a great session today. I hope we can have a few questions from our participants. And Annie, do you want to open up the chat and let us know what are the questions that are coming our way?
Hey, yes, absolutely. Good afternoon, everybody, wherever you are. Feel free to type your questions in the chat box for questions in the panel next to you, and I can see that there is a couple of questions coming in. To start with, somebody here is asking, how much does the FLS110 solution cost? Who wants to take that one? Is Tamar?
Yeah, we'll take that one. So again, for the FLUSO technology, with again, as we mentioned at the beginning of the webinar, it is MEMS-based, CMOS manufacturing process based. It's all a question of volume. So we have prices that varies depending on the volume, but we can certainly achieve a single-digit price when we get in the thousands of quantities. That's not a problem at all for us. And we can even be more aggressive than that if the volumes are much higher. So we have list price. If you go on DigiKey and some of the online resellers that are our partners, you will find the price of our sensors. But if you have, of course, an opportunity for larger opportunities in terms of volume, we can provide a specific quotation, and we can. You will really benefit of the technology by having large volume of course, right?
Excellent. I hope that one answers. And if not, just raise your hand and shout again, and we'll get back to you if you need more info. And the next one is for you, Chris. How much does the sensor weigh, please?
Yeah, it's a good question. I mean, certainly, I actually tried to weigh a sensor a little while back because I figured that for a drone application it would be important. And the sensor weighs significantly less than a gram. In fact, so much less that the scale that I was trying to use to weigh it couldn't weigh a single sensor. So the sensor really is just as light as a feather. It's much less than a gram, and certainly significantly lighter than any of the differential pressure sensors that we're competing against. So I think that's a big benefit of the very, very small form factor of our design. Once you start to include the weight of the pitot tube and the tubes that you'll need to interface with the sensor, really the overall weight will end up being the weight of those tubes and that pitot tube itself, not the FLS110.
Thank you very much. Awesome, Chris. Well, this one is for you as well. What is the power consumption of the sensor, please?
Sure. So typically the sensor would consume anywhere from 17 to maybe 21 milliwatts in a drone application, depending on the airspeed that the drone is going. So it's very, very low power consumption. it will be consuming much less power than anything like the motors of the drone or anything like that. So it's exceedingly low power. In applications where you might need even lower power, of course, we offer the option to duty cycle the sensor. So the sensor can be run in either a continuous or a single shot mode. In a continuous mode, you get 250 readings a second, which is ideal for something like a drone application where you're trying to monitor something in real time with a high temporal resolution. But if you're looking for a lower power application, then we would suggest running in a single shot mode where you could measure once a second or even once a minute. And once you start reducing the rate at which you're measuring, the power consumption comes right down into the microwatts range. So it becomes really applicable for battery powered applications where you're looking to take measurements over a long period of time.
Okay, I think that definitely clears that one out. We have got another one that asks if the FLS110 wind speed apply only to fixed wings or multi-rotor drones. That's very technical. There you go.
Sure. So the sensor is applicable to both. It's applicable to both fixed wing and multi-rotors. Typically, we are targeting fixed wings primarily because for a fixed wing, a measurement of the airspeed is very important to ensure that you have enough airspeed to generate the right amount of lift and that you're flying in the most efficient way so that you can achieve the maximum range for a given amount of battery power. When looking at a multi-rotor application, the FLS110 can be used to measure wind speed to improve things like endurance prediction and also to help the drone compensate for gusts of wind that might push it away from where it's supposed to be loitering. So for a multi-rotor application, having that ability to very accurately measure low wind speeds is really advantageous. It works with the GPS, so you have the GPS and the wind speed measurement, and by combining those two sources of data, the drone is able to be much more accurate in its position over a particular point on the ground and not move around anywhere near as much.
Okay, thank you very much. And I think that was the last question. Unless somebody is quick on the keyboard and just throw another question in the question box, but if not, doesn't look like it. I can't see anybody typing. So with that, I think we should wish everybody a happy rest of your day wherever you are, and say thank you very much. Tomas from hot Italy, Chris from lovely Cambridgeshire, and goodbye from us.
Thank you, everybody.
Thanks, everyone. See you on our next webinar. Take care. Bye-bye.
Bye-bye.